Hey there. So in this video, we're going to take a look at functions in Python. So functions are really useful things. They allow you to reuse your code so you don't have to write more or less the same thing over and over again. And it also allows you to better chunk your code to make it a whole lot more readable. So let's begin. So a function starts off with def, or define. So we're going to define a function, and let's just call it hello world, just like that. This is going to be followed by two brackets and a colon. And notice that as soon as I hit the colon, it then indented me. This is really important. Remember, Python uses indentation to show scope, so everything that is indented over is going to be part of my function here. And what a function is basically saying whenever someone runs hello world, do all the code that's inside here. Okay? And this is going to do just one thing. It's going to print, you guessed it, hello world. So just one thing. Not very fancy, but there it is. And say, okay, well, we got our function now. What happens if we run this thing? The answer is nothing. Nothing happens at all. Because while we have created the function, we have not actually called the function. So down here, we're actually going to call our function by writing hello world, exactly as we wrote it up here, followed by those two brackets. Whenever you see the two brackets, that's basically always a function call. And so we're looking at a function called hello world, calling that function which says run all the code in here. And there's only the one line of code that says hello world. So if we run this, now it says hello world. Okay? So that is functions in a nutshell. It's basically where you can put a whole bunch of code and then just call it with a one-liner. So if I wanted to do this a bunch of times, I could say hello world again. And it would do it twice. Just like that. So, sometimes, so functions are used for when you want to do things multiple times, but you don't want to rewrite the entire thing. I'm going to show you an example at the end of this of one reason why you might want to use this. But we need to take a look at a couple more things first. So what we just wrote is technically called a procedure. Procedures are just things that you run and don't have any return value. But for the sake of simplicity, I'm just going to call them all functions. They all behave exactly the same way. Some of them have some inputs, some of them have outputs, but they all do the same kind of idea. So let's do a new function. Let's call it hello name. And what we're going to do, rather than saying hello world, this is going to say hello and a person's name. But how are we going to tell it what name to enter? Well, rather than putting nothing inside those brackets, I'm going to put in name. What this is called the argument of the function. So the previous function that we took a look at, the hello world, had no arguments. Means that you didn't have to put anything in the bracket for it to run. This one is now expecting a variable, which we're going to call name. Doesn't have to mean that when you're calling it, it has to be that name, but we're expecting it to be that name. And so this is now gives us a variable called name, which we can then use inside of our function. And we're just going to use it, say print. We're going to use an F string here. F strings are the way that you do formatted strings or string templates in Python. It used to be a much more pain in the ass way to do it. This is a much cleaner way to do it. And so we're going to just say hello, and then I believe, and then we just put in hello name. So it's going to say hello and the name of whatever we enter in here. That's it. So if I then call my function, I can do hello name, and it's expecting me to enter a name in here, so I'm going to say Bob. And it says hello Bob. We passed it the string Bob, and it then used that inside of our function. I could also do, say, name equals, and note that these are have the same lettering. Let's actually change this. Let's call it uppercase name, and it's going to be Alice. So here I put in the string directly. I can also just put in a variable name to pass it the name that way. So I can say hello name, and this time I'm going to give it the variable name instead. If I run it, it's going to say hello Bob for this. Next time I pass a name, which is Alice, and it said hello Alice. So that is how we can pass variables outside the function into the function and use those in our code here. Okay, so that's how we do input. The other thing that we need to know is how do we get output from a function, because sometimes we want to pass something that's done in the function and pass it out to the rest of the program. So we got a hello name function. I'm going to call it a new function called add1. It's going to take a variable I'm going to call x. What it's going to do is we're going to take x, we're going to add 1 to it, as it says, and we want to pass this back out to the rest of our program. The way we do that is using the return statement. And we're going to return the variable x, whatever is being stored here. So we're going to take in the variable, add 1 to it, and then return that variable. And that is how we pass stuff outside of the function. So let's get rid of this stuff and try it out. So what I'm going to do is I'm going to print out add 1, and I'm going to give it the value 1. And if this function works, what we should see is that it prints 2. There it is. It took my 1, passed it to my add1 function, the add1 function added 1 to it, giving me 2, and then returned that 2. You can also do something like this. I can say y equals add 1, and then print y. Does the same thing, still 2. Whatever gets returned from the add1 function got assigned to the variable y here, and then when we printed y, it printed 2. Okay? So that is how we pass information out of a function. So, if you're familiar with the idea of input, processing, output, or IPO programming, functions are extremely IPO. They have a well-defined input, so you declare all your inputs here. Then you have a well-defined processing step, which is all the code inside, and a well-defined output, which is whatever your return statement is. So anything that you can write down as an input, processing, output, function is really well suited for that. And you should make a lot of use of functions. Like, don't just use them sparingly, use them a lot. As a general rule of thumb, if you start writing a section of code and it's about 10 or 15-ish lines of code starting to get up there, start looking at a way of how you could use a function in order to encapsulate some of that code. And that way you can use the function name in order to make it really clear what's going on, and let the function kind of take care of all the details elsewhere. So make lots of use of functions. They'll definitely help you out. So let's take a look at one really useful way of we can using functions, and that would be input verification. So we are going to make a new function, and we're going to call it the getNumber function. This getNumber function is going to get a number for us. We're going to say that we want to know what the type is, the minimum, and the maximum for this particular function. we're going to get 3 different variables that we're going to pass into it. But you don't always have to give these variables when you are calling a function. What we can do is we can give them default values, and then we can override them if we need to. So these are called keyword variables, or keyword. So we have the type, minimum, and maximum. We're going to say the type is going to be of the type int, so integer. And this is actually a function itself. It turns anything into an integer. The minimum we're going to say is 1, and the maximum, actually we're going to say is none, and max is going to be none. So we're going to say by default, the type of number we're going to get is going to be an integer. And we're not going to have any minimum or maximum value for this particular integer. So, now let's just do our input verification. The way that we're going to do this might be a little bit different than what you've seen before. We're going to use a proper error catching, because when we're trying to convert something into a number, if it is not a number that we're trying to convert, that's going to cause an error. And when we're working in JavaScript, we could use is not a number in order to try to catch that. But Python is just going to straight up crash if you try to do this. So we're going to use error catching in order to protect that. The way we do this is we do a try, or what's called a try followed by an except. I believe it's except. Yeah, that's fine. So in the try block here, we put in what is the code that we want to try to run and protect from crash. And the code that we're going to run here is getting an input from the user and converting it into the type int. So we're going to do, say, make a variable called num for number. We're going to use type. So this variable type is a function. It's currently assigned int. And then what we're going to do is we're going to get some input. Input, enter, enter a number. I could probably clean this up a little bit, but I just want to show you how it works. And if you guys want to use this, then you can clean it up so that it says if you want an integer or if you want a floating point, meaning a decimal number, if it has minimum or maximum, you can do all that kind of stuff in here with some if ands, or sorry, if else's, or even set up the stuff before the try. So what is the minimum, what's the maximum, figure out what you want to put in that string, basically. So we're going to try to convert it into the type by default int. And if there's a problem, meaning if this line of code causes a crash, that's going to trigger the except. And what that means is we try to convert it into something that it couldn't do. And when we do that, we need to give an error message. There was that. That's not a number. So we try to convert something that's not a number into a number. That would cause an error right there. One thing I did forget to do is we forgot to do a while loop. I am going to be lazy and do a while true loop. This can certainly be done without a while true loop, but for simplicity, I'm going to say it's a while true loop. So we're going to try to get a number from the user, assign it to the variable num. If we get an error, we're going to give an error message, and then we're going to use continue. What continue does is it goes back to the beginning of the loop and does it all over again, which means we're going to try to get another number. If we get past the except, that means that we did not get an error when we did this. And then what we'd want to do, so we do got an integer, we would want to check if it's in the right range. And so that's what we're going to do. We're going to do an if statement that will check if it's in the right range. And I'm going to do this in 2 if statements, just for the fun of it. So I'm going to say if our number is less than the minimum. Actually, I'm going to do if minimum doesn't equal none. I'm going to check this first, because if I try to do minimum check to check if it's less than the minimum, and the minimum is none, that's going to cause an error. So I'm going to first check if it's not none, and then I'm going to check if my number is less than the minimum. Okay? If I do this in the opposite order, I could get an error. So I'm going to do this check first, and if this fails, it won't even bother checking this. So it protects me from the error. I'm going to then print out an error message. That's below the minimum value. And if I want to do a good job here, I'd also say what the minimum value was. Should also be doing it here as well. But syllabi. Else if, I'm going to do the same thing now with the maximum. So I'm going to check, is max not equal to, sorry, not else if, it's elif. Elif, I was just doing some JavaScript, so bear with me. Elif max is not equal to none, and number is greater than max. Print that's above the maximum value. So once again, give them a relevant error message. Is it not a number? Is it below the minimum value? That's not how you spell minimum. Is it above the maximum value? And in each case, since it is a error, we're going to then go back to the beginning of the loop, try it all over again. And continue there as well. So I've done some checks. Remember, when you're doing input verification, always check for the errors rather than check if it's a good value. That way, if it is an error, you can give a relevant error message, but if you are checking if it's a good value and it fails, you don't know why it failed, so you can't give them a relevant error message. Always check for the bad cases. That way you can always give them a relevant error message. So, we're looping, we're trying to get an input. If it fails and causes a crash, our accept saves us, tells us that it wasn't the correct number, go back to beginning. Then we do a checks on minimum and maximums. And if they fail, go back to beginning, try again. And if we get so far that, get this far, it means it didn't crash and it's in the right range, we're just going to return that value. And that's our output. So let's see if this thing in fact works. So I'm going to do print get number. So all this is going to do is just echo back the number that we enter if it is a good number. And I'm not going to give it anything right now. The reason why I don't have to is because we've given default values to all of our parameters here. So if I don't put anything, it's going to use these values here. Okay? So I'm going to run it, enter a number. So we're right here. I'm going to say no. I'm going to play around. I'm going to say hello. It says that's not a number. Why did it do that? Because when it tried to convert it, it caused an error. And so it says that's not a number. And it went back to beginning, asking me for a number again. And since we don't have a, let's try to play around with it. Let's give it a decimal number. We don't have a minimum or maximum to play around with. Oh, that gave me an error too. Probably because I'm expecting an integer that's not an integer. So I should probably have some sort of check for that. You could do an except another check here to protect that, but I did not. And if I put in 4, that was an integer, so this did not crash. There was no minimum or maximum that we needed to check for, so it went right to here, returned to the value 4, and it got printed out. And that was the end. Let's try checking whether or not we can change these minimum maximums though. So now let's say we want a number between 1 and 10. What I'm going to do is I'm going to say min equals 1, comma, max equals 10. If you have undeclared variables that don't have alternatives, then you kind of have to enter in your values here in order. But if they do have alternative values, if you just want to write them in a different order, you can give the name of the parameter as it's declared and set its value here. So we're saying, okay, get the minimum value, set it to 1, the maximum value is going to be set to 10. Okay, so that's how we can change these default values. But we did not change this. This is still going to ask for an integer. Run it again. Once again, we're going to say hello. That's not a number. Still causes an issue. This is probably still going to cause an issue because we're trying to cast it to an integer. That's not an integer. Causes a problem. It crashes. But now let's try our minimum and maximum. Let's say 0. I expected 0 is less than 1, so that should cause a problem. It says, yep, that's below the minimum value. Ask me to do it again, so minimum works. Let's go above the maximum. 11. Nope, that's above the maximum value. It's supposed to be in between 10. But if I give something that's now in between, it's all good with it. It returned the value, and it got printed out, and the program stopped. Okay? Now finally, let's change this type. Type equals float. Rather than trying to turn it into an integer, we're going to turn it into a floating point number, which is just another name for a decimal number. So that means that this 0.4 that we saw should now work. So I'm going to keep all this the same. Run. Enter a number. Still going to mess with it. We're going to do 0. Still doesn't work. 11. Still doesn't work. But now what if I do 0.4? Last time it crashed because it said 0.4 was not a number because it's trying to turn it into an integer. Now we're trying to turn it into a floating point. So this no longer caused an error. That's why I got past this and it didn't say that's not a number. Instead, it got caught here because 0.4 is less than the minimum value of 1 that we set. But I can do it again. Now I can say 5.5. Still a decimal number, but it is between 1 and 10, so it's happy with it, and that's what it returned. Okay? So that is an example of how you might use a function and allow yourself to reuse it over and over. Because using input verification is a common thing. You're probably going to get multiple types of input from the user depending on what you're doing, and you don't want to have to rewrite all of this every time you're trying to get an input from a user. That's just a whole lot of rewriting the same code over and over again. No one wants to do that. Instead, you can just create this getNumber function. You can give it some flexibility by giving it these optional parameters. So you don't have to actually put in a parameter if you don't want to, but if you do, we can now set it so that it will enforce a minimum value. It will enforce a maximum value, or you can change whether or not it's getting an integer or a floating point number by changing the type. And now we got this getNumber function, which we can use for getting a number from the user, ensuring that it's the right type and in the right range if necessary, then returning it so that we can continue on with our lives. And you only have to write this once. And everywhere else in your code down here, you can just call getNumber, put in whatever parameters you need in order for that particular purpose, and get the number knowing that you can be safe, knowing that it's going to in fact be what you think it is. So that is an example of using a function and what functions are all about. So I'm going to stop there. Have a good one, and we will continue this another time.